In this video, I'm going to go over how to solve 4 different systems using the elimination method. We're going to combine the 2 equations in an effort to figure out where the 2 lines intersect. Let's get to it. The elimination method is one of many methods that you may be learning on how to solve systems. So we're going to be taking these 2 equations, and I remember learning this in high school and just being blown away. We're going to take these 2 equations, we're going to add them up and create a new 3rd equation that will help us to solve the system. So let's actually look at this first system. Now, one way to think about these that I think is very helpful is that these are number riddles. We're trying to figure out 2 numbers. We'll call them x and y. And I have two clues to this riddle. The first clue is that they add up to be 5. X plus y equals 5. And then the second clue in this riddle is that 2 times the first minus the second, so 2x minus y, that's 7. So what is the solution? What are the 2 numbers? We have 2 unknowns and 2 clues, 2 equations, so we can solve this system. So the elimination method is where we're going to try to eliminate one of the variables, get it to add up to 0. We're going to add the 2 equations up and watch what happens on this very first example. We get 3x because 1x plus 2x is 3x, and then the y's add up to 0. Now, I'm not going to write a 0 down below because that'll just get in the way. I'm going to bring my equal sign down, and then 5 plus 7 equals 12. So isn't that kind of interesting that we could take 2 equations that are both true, we can merge them together through addition and create a 3rd equation, and one of the variables is gone. We've got 3 times x is 12. Well, now it's just a linear equation. We can just divide by 3 on both sides. Super simple, right? X equals 4. So remember, we're looking for the point of intersection of these 2 lines. So x is 4. I'm going to put that in my coordinates there. So how do we figure out y? Well, you just substitute your answer, your x equals 4, back into one of the equations. Just pick your favorite one, whichever you think is easiest. I'll pick the first one. X plus y is 5. And remember, we just figured out that when x is 4, we need to know what y is. So I'm plugging 4 in for x. That's called substituting. I'm now solving for y. Y equals 1, and I can put that in my answer. The answer is 4, 1. Now, we can check our work, of course, check our work by plugging that back in up here. Do they add up to 5? 4 plus 1, yes, they do. Now, 2 times 4 is 8. Minus 1, does that equal 7? It sure does. You see, this combination 4 and 1 works in both of the equations. And we use the elimination method very strategically. We added all the like terms vertically and had an equation, 3x equals 12, that we were able to solve. So let's move on to the second example. This is about the same level of difficulty. I want you to look at this. What's going to happen if we add them up? The x's are going to add up to 0. See, that's one thing you're going to need to start to look at is predicting or seeing what's going to happen if I add them up. So if I add them up, does anything add up to 0? The answer is yes, so let's do it. Let's add these 2 equations up. We get 8y equals 16. Once again, a simple equation that we can divide both sides by 8. We get y equals 2. I'm going to put my answer down here. Now this time, and I did this on purpose, of course, this time we got y first. Sometimes that happens. Now, do you remember how we figure out the other variable? Because that's a common question I have from students. I get the first number really easily, but Mr. White, how do I get that second number? Plug in y equals 2 to either of the equations. I'm going to use the second one. So x plus 5y equals 7. So x plus 10 equals 7. I subtract 10, I didn't mean to put that x there. I subtract 10 from both sides, and I get x equals -3. So I'm going to plug that into my point. The answer is the coordinates -3, 2. That's the point on the graph where if we were to graph these 2 lines, that's where they would cross. That's where they would intersect. Now, before we get to the third example, I need to talk to you about something. Take a look at this simple linear equation. 2x plus 1 equals 7. What's the answer here? What does x equal? So you're imagining yourself minusing 1 on both sides, divide by 2. X equals 3, right? X equals 3 is the answer. Well, I want to ask you, what if I doubled everything in the problem? So I'm going to cross out the problem here, and I'm going to write 4x plus 2 equals 14. So what is the answer now? I doubled everything in the equation. Is the answer different? Is it x equals 4 or 2 or something else? Of course not. If we minus 2 on both sides, we get 4x equals 12. Divide by 4. Look at that. X is still 3. If you multiply the entire equation by the same number, in this case 2, everything in the problem by 2, you got the same equation on your hands, so you're going to get the same answer. Now, we could have multiplied everything by 3 or 4 or -1 or -2, and we would still have gotten x equals 3. So by multiplying everything in an equation by a number, it doesn't change the equation. That's my point. This is called a transformation. This is called a transformation, and we're going to need this skill in the next system. We're still going to use elimination method, but we're going to need to use a transformation. So I want you to look at this problem. Does anything add up to 0 right now? Like if I were to just add things up, I would get 5x plus y equals -3, and that doesn't help. That doesn't, and nothing adds up to 0. So what if maybe we multiplied one of the equations by some number? Would that be helpful? Now, this is the challenge, is you have to pick that some number, and it's different, potentially different for every problem. So I'm looking here, and I see just one really easy way to do this. There's many ways to do it. One really easy way would be to take this second equation and multiply everything by 2. Now, why would I do that? Why would I do that? It's so that I can turn this right here into a -2, and you see what's going to happen in the future, right? You see that? Now, I got to get that out of the way because I don't want that 2 there just yet. I am going to rewrite this whole system down below. So I'm not changing the first problem at all. I'm not changing that at all, but I am going to take that second equation and double it. So I'm going to multiply everything by 2. So I get 4x minus 2y equals -8. Now, after that transformation, if we add the two equations together, the y's add up to 0. We get 7x equals -7. Divide by 7, you see that x equals -1. We could not have gotten that first answer, x equals -1, without that transformation. So the first part of the answer is -1 comma something. So how do we find that second number? We go back up top to one of the original equations. You could use your transformed ones, but hey, let's go back to the ones that have the smallest numbers, which are way at the top of the screen there. So I'm going to use 2 times x minus y equals -4. And I'm going to put that -1 in there. So 2 times -1 minus y equals -4. -2 minus y equals -4. Then we add 2 to both sides. So we get -y equals -2. So therefore y equals +2. And we go ahead and put that into the coordinate over here. The answer is the point -1, 2. Now this elimination method is really a slick way to do these problems. I think you would agree the substitution method would have been quite a mess if we had substituted one equation in the other. And maybe we don't have a graphing calculator handy to be able to graph these two lines and figure out where they hit. The elimination method does it really quite simply, even with this transformation that we had to do. Now I have one more example lined up, and this is the third level of difficulty. So we did level 1, that's where it was set up all ready for you. Level 2 was a 1 transformation. This is called a double transformation. Now why would it be a double transformation? Well, if you look at this problem here, 3 plus 2, of course, that's not 0. I can't really easily turn a 2 into a -3, right? And I can't very easily turn a 3 into a -5 or a +5. So we're going to use different numbers for the different equations. Okay, we're going to use different transformations for the different equations. Now, listen to me carefully, we need something to add up to 0. So you're going to have to make the executive decision. You're going to need to decide what your goal is here. So my goal, I think, is going to be to turn this into 6x and negative 6x. All right, and then the x's will add up to 0. So I can do that, right? I can take the first equation and multiply by what? How are we going to go from 3x to 6x? That's going to require multiplying by 2. So I'm going to multiply the rest of it by 2 while I'm at it here before I forget, right? And don't forget to multiply the right side by 2. That's a common mistake. Now, looking at the second half, I need to turn a 2x into a 6x. A 2x into a 6x. So what's it going to take? How about multiply by negative 3? Multiply by negative 3. So this is going to become positive 9y equals negative 6. So just keep your work nice and neat and organized, and then hopefully here in the end we're going to get a nice round answer. Let's see. Let's add these two equations up now. We get negative y equals 2, so y equals negative 2. Well, that wasn't so bad. Now let's go up to one of the original equations. I'll use the second one. 2x minus 3 times my negative 2 answer is 2. So 2x plus 6 equals 2. I'm going to minus 6 on both sides and divide by 2, x equals negative 2. So the answer, if I write it as a point, would be negative 2, negative 2. And that's the elimination method. Sometimes you have to use transformations, and sometimes it's as easy as the first couple that we did. Now, if you enjoyed this video, if you found it helpful, be sure to like and subscribe, and don't forget to leave your comments down below. I do enjoy reading them. All right, until next time.